here what we've got is we've got a H₂SO₄ reacting with NaOH, and that produces Na₂SO₄, so that's sodium sulfate effectively, and H₂O. And we've been asked to calculate the mass of H₂O that's produced from this reaction. So how are we going to do that? Well, what we've been told in the question is that 18.59 grams of H₂SO₄ is what's reacted, and the NaOH that it reacts with is in excess, right? Now what that tells us is that the limiting reagent in this particular case is going to be the H₂SO₄, not the NaOH. Therefore, the most relevant detail here for relating to working out the mass of H₂O produced is the amount of substance of H₂SO₄ produced, right? Because then we can work out through the molar ratio, etc., etc. We can work out the H₂O. We don't even have the amount of substance yet, but we do have a mass, right? So because we've got a mass, we can use the equation that the mass is equal to the moles multiplied by the molar mass mR, right? We can use that to effectively work out an amount of substance. So if we rearrange this equation, so by dividing both sides by mR, of course, what you find is that this gives you an equation that says that the number of moles is equal to the mass, right, divided by the molar mass, right? So if we want to work out the number of moles, we're going to need to divide the mass, which in this case is 18.59, by the molar mass of, in this case, H₂SO₄. So in order, obviously, to work that out, we need to get the molar mass of H₂SO₄, and we can use the periodic table to work that out. In this case, H₂SO₄, that would be, so for hydrogen, we've got 1, right? So we've got hydrogen, sulfur, oxygen. So for hydrogen, it's going to be 1 multiplied by 2, right? So H2, right? So H2 in there. And then we need to add that to effectively the sulfur, which would be 32.1. And then we need to add that to the oxygen component, which is going to be 16 times 4, right? And so from there, if you work that out, you should find that you get 98.1, right? 98.1. And okay, so, and that's in grams per mole, right? So that's the mR of H₂SO₄ is equal to that. Okay, so with that 98.1, as we discussed, we're going to effectively need to divide. We're going to need to divide 18.59 by this value. So so now we're looking at the number of moles of H₂SO₄. That's going to be equal to 18.59 grams divided by 98.1 grams per mole, right? So I invite you to have a go, figure out what you get when you do calculate that. But if you do, you should find you get 0.189 5015, and that would be in as you can, we know this is in moles, but you can even work out the units from this. So grams divided by grams, obviously that cancels out. Then moles, like divided by moles to the -1. So obviously that resolves to be just moles, right? So, and then with this is our mole value. So if you can now compare, so for each mole of H₂SO₄, how many moles of H₂O do we have? So you can see here in this which is a balanced equation, H₂SO₄, you've got the coefficient, if there was one, would be 1, right? And here the coefficient is visible, which is 2. So for every mole of H₂SO₄, you're going to get 2 moles of you're going to get 2 moles of H₂O, right? Because of that, we know that the moles, so let me just formalize that by writing it, right? So when it comes to the moles of H₂SO₄ compared to the moles of H₂O, you're going to have a 1:2 ratio. Is effectively, so therefore the moles of H₂O is going to be equal to simply the 0.189515 multiplied by 2. Okay, so that's going to give us effectively 0.379003 moles. Okay, now we've got this value, but what we need to do is we need to work out because this gives us the amount of substance. It doesn't give us the mass, right? So it says calculate the mass of H₂O produced. So we need the molar mass of H₂O to work out the next step, because as we know, the mass, so the mass is equal to the moles, which we have here, multiplied by the mR. Right, in this case, it's in relation to H₂O. So if we refer back to the periodic table, we'll be able to work out the molar mass of H₂O if you don't know it already, even though it is quite a commonly known molar mass. We've got H, which is 1, and then the O, which is 16. So that's going to be H₂O. So it's going to be effectively 1 times 2. So that's the molar mass of the hydrogen times 2, because it's H2, plus 16 times, effectively it's times 1, right? So and of course this will give us 18. So there's the mR of H₂O equals that equals 18 grams per mole. And so effectively the mass of H₂O, so we've got all of this, therefore the mass of H₂O, that should be a lowercase, to be honest. Mass of H₂O is going to be equal to 18 multiplied by the above calculated value, so 0.37. And so, feel free to have a go to see what you get when you do run that calculation. You should find that you get 6.8222054. And that's going to be in grams, right? Okay, so this is the value we've so far calculated. Let's check what the question actually asks us to do. The question says, calculate the mass of H₂O produced. Please give your answer to a maximum of 2 decimal places, right? So therefore the moles, not the moles, the mass of H₂O is actually going to be equal to 6. So we effectively need to round that to 2 decimal places, right? So 6.82 grams, right? And so this would be, in this case, this would be our answer, all right?